right, let's look at another example here. We're still working with subtraction. Now, remember, the first thing you will do is find your least common denominator before you can start subtracting these expressions here. So let's go ahead and factor each one of these denominators out. You have x squared minus 16, which will factor out into x plus 4, x minus 4, using the difference of squares formula. Okay, because again you can write 16 as 4 squared, so that's where you get the 4 in your factors from. And then we'll factor x squared plus 8x plus 16. Okay, again your leading coefficient is 1, so this will just be x and x. Now you want to find factors of 16 that will add up to give you 8, which will of course be 4 times 4, and they will both be positives. Okay, now once you factor your two denominators out, you can start finding your least common denominator. Now you can see you have x plus 4 common between the two denominators, and in the second one you have x plus 4 that appears twice. So in your least common denominator also you will have x plus 4 two times, because again remember, you always use the greatest number of times a factor appears. And then of course the other one is x minus 4, which appears only once in the first denominator. So your least common denominator will be x plus 4 quantity squared times x minus 4. Now, once you find your least common denominator, you will have to make both these denominators look similar to the least common denominator. So let's go ahead and start by rewriting our original expression here. Okay, now before I will start finding my common denominators, what I will do is just rewrite these expressions again with the denominators in their factored form, because that will help us out better. Okay, now we can go ahead and compare these with our least common denominator. So if you look at this, your least common denominator is x plus 4 quantity squared x minus 4. Looking at our first denominator, you have 1x plus 4 and you have 1x minus 4, which tells us that we are missing 1x plus 4 in our denominator here. So we multiply our first expression by x plus 4. So of course you want to multiply your numerator also by x plus 4. And now you can see your denominator looks the same as the LCD. Your second denominator has only x plus 4 quantity squared. So from your LCD, you're missing the x minus 4. We'll go ahead and multiply this into x minus 4. And now we can start solving these expressions. So let's go ahead and see what our equivalent fractions will be here. You have 2x times x, which will give you 2x squared. Then you have 2x plus times 4, which will be 8x. And then your denominator will be x plus 4 quantity squared x minus 4. On the other side, you multiply the 3 with x minus 4, and that gives you 3x minus 12. And again, the whole thing over x plus 4 squared times x minus 4. And let's see, that will give us 2x squared plus 8x minus, and then again remember, always put the second numerator in parentheses, and this whole thing now will be over the common denominator. Right, so let's see what will happen when we simplify this. You will distribute that negative sign, and you will combine your like terms, and after combining your like terms, you will end up with 2x squared plus 5x plus 12 on your numerator, x plus 4 quantity squared, x minus 4. Now, once you get to this stage, you again want to try and see, okay, can you simplify this any further than what you have here? So again, you want to try and factor the 2x squared plus 5x plus 12 and see what you will come up with. So let's go ahead and factor our numerator here. And let's see what we will come up with. So when you are trying to factor let's see, you will have now remember we had talked about this earlier. When you have a leading coefficient of 2 or anything other than 1, your factoring process will change a little. Now for your leading terms in the factors, you will have 2x and x as your two terms, because again when you multiply these you should go back to 2x squared. Now to factor this, you will multiply 2 into 12, which will give you 24, and then you need to find factors of 24, which will give you a positive 5, and you can try and see different combinations. So two numbers that will multiply to give you positive 24 and add to give you a positive 5. So if you go through the list, you of course have 24 times 1, and then 12 times 2, 6 and 4, 8 and 3, just different combinations that you think might work for you. And the only two numbers that would possibly work is if we had positive 8 and negative 3 that would add to give us a positive 5, but when you multiply them they give you a negative 24, whereas we wanted our product to be a positive 24. So what that tells us is basically that you cannot factor this any further, and this will be your final answer in the lowest terms. But remember, you always want to check and see if it's going to factor or not. And as you can see, we tried factoring it, but there's just no way this will work. Now, the other thing you can do is try and use the quadratic formula. I'm sorry, not the quadratic formula. You can try and possibly try some other factoring methods and see if you can factor this out, but this will be in lowest terms, and that's how far we can go. All right, let's look at one more example on how to add and subtract if it were involved in the same example. So you can see here we are adding 2p over p minus 3 with 2 plus p over p, and then we're subtracting that from negative 6 over p squared minus 3p. So first thing you will do is find your least common denominator. This time you are working with 3 denominators, okay? So p minus 3, you cannot factor that any further. That is already in its factored form. Same thing with p. You cannot break it down any further. So you can leave the first two denominators as it is. Now for the second one, you have p squared minus 3p. You can see that p is common between both our terms here, so you can pull that outside as your greatest common factor, and you will be left with p minus 3 inside the parentheses. So now that each of our denominators are in the factored form, we can go ahead and find our least common denominator. Now you have p that is common between the second and the third denominator, and both of them appear only once, so you will go ahead and write p as your first factor. Then you have p minus 3, which is common between the first and the third denominators. Again, they appear only once, so your common denominator is going to be p times p minus 3. Now, looking at our original problem, we want to try and make all our denominators the same. So we need to multiply each one of these expressions and try and find our common denominator. So this tells us that we need to multiply our first denominator by a p, because you have p minus 3. The only thing missing is a p. So we multiply our first expression by p. Okay. Looking at our second expression, your denominator is p, so you're missing p minus 3. So we'll multiply second denominator, or the second expression, by p minus 3. All right. And then let's look at our last expression here. Now your denominator is p squared minus 3p. Instead of writing it in that form, I'll go ahead and write it in its factored form, which we had done here. You can see it's p times p minus 3. It's just easier to work with it in that form. And as you can see, this is the same as what our least common denominator is. So we really don't have to multiply this expression by any other factor. It's already what we're looking for. So now you can see all our denominators are the exact same, and you can go ahead and simplify your numerator and then combine all your like terms. So this will give me 2p squared for the first one. Okay. For our second one, you will have to FOIL these two. So you'll take 2 times p, and then 2 times negative 3 will be negative 6. Then you multiply p times p, which will give us p squared, and then p times negative 3. And of course, we didn't have to multiply this anywhere, but remember, you have this negative sign in the middle. So you will have to put the negative sign from here, and then this numerator, negative 6 in parentheses. And this whole thing over our common denominator. Okay? Now, let's go ahead and simplify our numerator and see what we come up with. So you have 2p squared plus p squared. So you can go ahead and combine these like terms. So 2 plus 1 will give you 3p squared. You have 2p, negative 3p. So those will combine to give you a negative p. And then let's see. We took care of these. Now you have negative 6. And remember, negative and negative will become positive. So maybe we'll go ahead and write it down like this. Negative 6, this guy becomes positive 6 over your common denominator. And then that leaves you with 3p squared minus p, because again, negative 6, positive 6 will cancel out. And you're left with 3p squared minus p over your common denominator. Now again, you can see, you can go ahead and try and see, okay, can you factor this any further? Can you put this in more lowest terms, smaller terms? So you have a p common between your numerator. Go ahead and pull that outside, which leaves you with 3p minus 1 over p times p minus 3. And you will see that once we factor this out, our two p's on the numerator and denominator will cancel out. And in lowest terms, this expression will be 3p minus 1 over p minus 3. So as you can see in our last example, when we tried to factor, once we got to this stage, it would not factor any further. So we left it as, that answer. But here, you could have factored it further. And now, once you get to this stage, this is the smallest this expression will be. You cannot put it in any more lower terms than this. And this is how you will go ahead and work with, if you had, let's say, an expression that has both addition and subtraction in it. So this is what we will do.